SwayamPrabha. Digital India. Educated India.
Welcome to the class of Intelligent Product Design. So far, we have talked about the structures, the mechanisms. We have also talked about the how to make it active, that means how to have sensors as well as actuators, so that it goes towards an intelligent system, and also we have talked about controllers. Now, we have talked about controllers, but we really do not know how to implement such controllers. Okay? So, in order to do that, today we will talk about that most effectively utilized technology to design controller and also integrate all the sensors and actuators in a closed loop system. In other words, today I will talk about the microcontroller and the microprocessors. Okay? So, that is something which is like the brain of an intelligent system. So, what is this brain of an intelligent product? Well, if you look at it, that there are two different types of elements we can use. One is called a microprocessor, another is called microcontroller. Each one of them has its own regime where it will be effective. Okay? Suppose I am talking about the core, then in the core the microprocessor has CPU embedded into it, something like you would see in every computer. Microcontroller, on the other hand, is more like on its own, but in a much smaller version, which has CPU, RAM, flash and other peripherals all embedded into it. Application wise, as I was telling you, that microprocessor is used mostly for computer systems, but microcontrollers are widely used in the embedded system, which is mostly important for us. So, we do use sometimes microprocessors, but that is for hardware in loop simulations, just to see how the system is going to behave. And because for that we can employ a computer, okay? But once we understand how the controller is going to behave, we actually upload the program in the microcontroller, and then from the microcontroller we run the entire system. Why do we do it? Because microprocessors are required for large scale processing, but an intelligent system on its own does not need typically a large scale processing, unless you network it, and then of course you can use the cloud computation in order to network the system. So, for microcontrollers we can use it for small scale processing. You have a few number of sensors, one or two or few actuators, and then you want to have a closed loop system with them. Microcontroller is much better because the weight penalty is much less. You can embed the system inside. On the other hand, you have to carry a big computational system for a microprocessor. So, no wonder that these microprocessors are used for PCs, mobile phones, Raspberry Pi, etc. But microcontrollers are like Arduino, STM32, MSP432, which are used like on-site applications. Another point we have to keep in our mind is that microcontroller is much simpler to use in comparison to microprocessors. So, let us first focus on microcontroller. So, what is a microcontroller? Microcontroller is a computer placed, let us say, on a single integrated circuit chip. Okay? A single chip which can work like a memory, which can have a processor and can have all the input output interfaces. Microcontrollers are programmed to run a specific task, which means if one needs to change or enhance their functionality, every time I need to install a new program on the chip. So, that is something that is a limitation, but also that is what makes it lighter. Now, microcontrollers can be found in almost all day-to-day items, like let us say your microwave ovens, TV, okay, toys, vehicles, what not. I mean, everywhere you will see a wide array of microcontrollers are present. Particularly one that is very famous is called Arduino. So, a lot of focus of today's talk will be related to Arduino. Based on its size and capability to handle complexity, different versions of Arduino boards are widely available in the market. For example, Arduino Uno, Arduino Nano, Arduino Mega, etc. So, I will talk more about such applications, particularly with a focus on Arduino Uno. Now, Arduino typically, which is a microcontroller family, Arduinos, there are all these things, but they can mean three things. One is a physical piece of hardware and a programming environment, and then a community and philosophy. Arduino is a open source hardware, and that will have two important things in it. One is a Atmel microcontroller based programmable circuit board, and the other is a easy to use software IDE, that is the integrated development environment software. So, you have a hardware and a software, Atmel and IDE. These two things together can create very easily some of the simplest Arduinos or microcontrollers. Basic feature of an Arduino Uno is that its operating voltage will be about 5 volts. So, you do not need a very large voltage. Its input voltage can vary between 7 to 12 volt, and it can regulate the input voltage, but we have to take care that the voltage is not higher than this, then it will burn the Arduino. Input voltage limits is given 6 to 20 volt, and typically it is going to have about 14 pins, input output pins, in which these are digital input output pins, which will be 14, okay, of which 6 will provide the pulse width modulation type of output PWMs, and analog input pins will be about 6. DC current per pin is about 40, input output pin is 40 milliampere, and for 3.3 volt pin it is about 50 milliampere. Now, other than that, the memory is like 16 KB if it is at mega 168, or 32 KB if it is at mega 328, of which 2 kilobyte is used for the boot loader part, and rest you can upload your program. It also has some SRAMs and EEPRAMs, and the clock speed is about 16 megahertz for such a system. Now, how Arduino has changed the prototyping of the electronic circuits radically? First of all, as I told you that the ease of use is very much there in such a system. It is designed in that way. Secondly, Arduino is open source. You do not have to pay for using the firmware libraries. On the other hand, there are systems like Raspberry Pis, etc., in which you may not get the open source. You may have to pay for the software or the hardware. Community, Arduino has a larger community support. Integration wise, Arduino boards can integrate with other technologies very easily, like sensors and actuators, to create prototypes that can then interact with the environment. So, Arduino is something which helps the prototyping for everyone. So, it is done in such a manner that even if you do not have the intricate knowledge of the computational system, you should be still able to use it. And you can use it for rapid prototyping. Free software, I have already told you that the IDE is a freeware, and it is of course inexpensive, the basic Arduino boards. In fact, if you look at the history of Arduino Uno, 2005 is the first time the project is launched by Massimo Banzi, leading a team in Ivrea of Italy, and then 2009 the system is introduced, the Arduino Uno system, as a part of the Arduino ecosystem. And just for curiosity, that in Italian means one. Okay, so making Arduino Uno as the first in this series, and it became of course very popular. So, this person's contribution is huge in terms of development of intelligent products in which the controller is accessible to everybody. Now, specifically, what is the anatomy of Arduino Uno? Arduino Uno has the microcontroller, of course, which is the brain of Arduino, and here the programs that contain logic to translate inputs to desired outputs, we load them. Okay. So, this you may think of it as a tiny computer. Other than that, it has USB ports which is used to connect Arduino to a computer. Okay, if you want to upload a program, download the results, etc. Then USB to serial chips are there for the serial communication, and then there are digital pins. So, pins that will use the digital logic. Okay. So, commonly 0, 1 or low to high. So, that is generally used as switches for turning on and off. Let us say you have to turn on and off an LED, then this high for the on situation and low when it is not there. So, that's like that you can actually work on it. Then the analog pins, pins that can read analog values in a about 10-bit resolution, and of course, you have 5 volt and 3.3 volt pins. These are used for the external powering external components, and then there is a ground. In order to complete the circuit, you will always need a ground point, and you also need voltage in, where you connect it with the external power supply. So, that is the anatomy, and you can see it where each one of them. So, here you will see the microcontroller at slightly the right bottom, and then you will see the pins are all arranged. So, first of all the USB port is on the left side, then USB to serial chips somewhere here, then you have the digital pins here, and then you have on the other side of these microcontroller, you have the analog pins first. So, the analog pins, then you have specifically the V input, you have the ground at the center, and on the other side you have 5 volt and 3.3 volt pins which is used for powering external components. So, that is the sort of an anatomy of an Arduino Uno. Now, let us say some basic circuit. Suppose I want to sort of switch on and off an LED circuit. Okay. So, in this case we have to sort of Arduino we have to use. So, in which the LED will be connected via a resistor, so that high current would not go to the LED, and finally to the ground pin, and when this pin is set to high state, the microcontroller on the Arduino board will allow current to flow through the circuit, which will turn on the LED. So, high state will put the LED on, and when the pin on the other hand is set to low volt, then the LED will turn off. So, as an electric current is not flowing through the circuit. So, this you can actually control through a kind of a programming. So, using now then the Arduino software, that is the IDE. Okay. So, Arduino software, if you is an open software, so you should start to learn it. So, if you open up the software, you are going to see that the editor is going to have some important areas to work on. First of all, it is going to have a toolbar with buttons, so which will have all common functions and a series of menus. So, the toolbar will allow you to verify and upload programs, create, open and save sketches, etc. Then you have a message area which gives feedback while saving and exporting, and also if you have some display error. Then you have a text editor, and where you are writing your own code, and then you have a text console that displays the text output by the Arduino software, that is the IDE. So, all these things together actually constitutes the IDE part of the software. These are some examples that are related to this system. Let us say first important thing is how to do the binary conversions in a system. So, decimal is the world in which we always live, but for the microcontrollers we have to translate it to the binary world. Okay. So, in order to do that, you need to, let us say, from a decimal to binary, you need to continuously divide the decimal by 2 and write down the remainder in reverse order. Okay. For example, if it is 162 to binary, so divide 162 by 2 repeatedly until the quotient is 0, and thus this way if you do, you are going to get a string of 1 and zeros. So, here is some examples that is given. Okay. So, you can practice that given different numbers how to get the binary code. And similarly, if I know the binary code, and then I can use the kind of a expansion of each of the positions in terms of the binary code. Okay. So, for example, if your signal is say 110101, that is 1, 2, 3, 4, 5, 6. Okay. So, you need to calculate this, so you need to go for 1, and then you need to see what is the corresponding value of these the nth order, and then you have to go for 2n minus 1. Okay. So, and then 2n, like that you have to come down till 1 star 20, and of course, if there is somewhere there are zeros, those things will not have any effect on the system, and thus afterwards by summing the system you will get the number. In fact, you can also check it this way, that digit positions are known. So, you have one slightly different problem, 1 0 0 0 1 0. First you put the digit position starting from 0, 1, 2, 3, 4, 5. Okay. So, what is the place value of this part? That is 1 into 2 to the power 5, that is 32. Next value is 0, then 0, then 0. These are, here it is 1 into 2 to the power 1, that is 2. So, the total summation is 32 plus 2, because this is also 0. So, this becomes 34. So, this kind of a simple conversion from decimal to binary, binary to decimal, you need to continuously do in order to carry out the program. That is one important part. The other important part is what we call it as pulse width modulation. So, pulse width modulation is a digital technique that controls a signal by repetitive switching of the signal between a high state and a low state. So, thus you can create this pulse width signal from a DC volt. Okay. So, for example, you can see in this case when it is a 50% on 50% off, then you get a pulse like this from a DC signal. Okay. And then if it is say 20% on 80% off, then in that case you get it for a smaller duration of time. This is on, and then it is most of the times off, then smaller duration time on, then come down. So, you create a different on off sequence. If it is just the reverse, 75% on 25% off, then you get a different type of a pulse that you can control. Now, pulse width modulation is very useful in controlling the average power or amplitude delivered by electrical signal. Okay. In fact, many times we run an electrical system not by a simple DC, but by a modified DC. In such a case, pulse width modulation is extremely good. For example, you are controlling the LED brightness. So, PWM can be used to control the brightness of the light, okay, by adjusting the duty cycle, that whether it is on for how much percent of time and how much percent of time it will be off. And similarly, you can use it for controlling the motor speed also. Okay. And again, there are other applications like a solar panel output and adjusting the screen brightness. Many such applications are there for PWM. Now, here is a very simple Arduino project. You should try it on your own, because design is all hands on, which we cannot do through a lecture. Okay. First collect some LED, then collect some resistor, a breadboard, Arduino Uno, jumper wire and USB cable. Okay. Keep all of them with you. Now, we are going to control only one LED in this program. Okay. And then you have a resistor of say 330 ohm. As I told you, you need always a resistor to bring down the current, and the breadboard is somewhere where we will be developing the electronic circuits, and we will be also attaching the Arduino Uno, let us say R4 or earlier versions. And then we have jumper wires, which are simple electrical wires with connectors on both ends, used to create the connections between various electronic components or points to a circuit or a breadboard. Now, in this simple Arduino board, as you can see it here, the shorter leg of an LED. So, this is a LED blinking project, let us say. The shorter leg of an LED called the cathode, that is a, so you have two legs on the LED, as you can see. So, the shorter leg is the cathode, and that is the pin that goes to the ground of the Arduino board. So, connect it to the ground, that is why it is connected to the ground. Okay. Connect the longer leg of the LED, this one, to the resistor that you have, so that you protect it from high value. Connect the other end of the resistor now here to the pin number 13 of the Arduino board, and connect USB to the Arduino board. Okay. So, these are the basic configurations that you can create. Now, you can write a simple code. Okay. We have given a simple code for LED blinking. So, we have defined this LED pin 13 and the delay time as 1000, and then we have put this setup code pin mode LED pin output, and then we have given this loop part of a program. So, this program can be written on Arduino IDE, and then we can upload it to the Arduino board. The code is having 3 parts. In the first part, we have declared the variables, just like we do it for any such language, C or something similar, very similar. Then the setup part, here the input output pin functionalities are assigned, that which pin is going to work for what, the pin modes are assigned. Okay. That is the setup part, and then the final part is the loop part, as I told you. So, this is the loop part of the work. The code written in this section will keep on repeating until the microcontroller is switched off. So, you can see if I upload it, how it looks like. So, this becomes a kind of a LED with a blinking control system. There is an online simulator. We have given you the link for a free online simulator, and then you can utilize this in terms of developing your own program and tinkering with it and run it at different duty cycles, just to see how you can integrate Arduino and a sensor for your intelligent product design. Now, although we have shown a very simple one, but really sky is the limit for this work, because LED blinking is just the beginning. Very soon, when you do it, you can actually use it for autonomous line follower robot. You can use it for real time weather monitoring. You can use it for a smart irrigation system, a programmable Arduino robotic arm, humanoid robot. Many applications people have developed on the basis of this Arduino Uno. And remember those 3 parts of the programming part of it. Okay. So, now I will come to the microprocessors. Now, microprocessors can do whatever microcontrollers can do, but they are actually much more powerful, but also they are kind of a dedicated type of a system. They need all the peripherals accompanied with them. Microcontroller does not need it. Okay. So, they have to be accompanied by ROM, RAM, timers, etc. And microcontrollers are designed to perform specific tasks, whereas microprocessors are more of general purpose device. Okay. I can give you an analogy, like we have peripheral nervous system and central nervous system. Peripheral nervous systems are somewhat like microcontrollers, which are specific to a task. Okay. On the other hand, our brain, which can do all sorts of things, they are more like a microprocessor system. So, microcontrollers do not need an operating system to process the data, but microprocessors do need, and Linux, Windows, Mac, etc., any one of them we can use. Microcontrollers naturally consume less power and are cost effective, whereas microprocessors are more expensive. So, this is the typical configuration of a system where you can have timer microprocessor connected with timer, connected with input device, output device, RAM, ROM, read-only memory, and the serial interface. So, commercially many companies actually do this. However, in this case we will discuss about Raspberry Pi, which we use most of the times. So, what is Raspberry Pi? Raspberry Pi is a series of small single board computers developed in UK by the Raspberry Pi Foundation to promote the teaching of basic computer science in schools. So, the original model became far more popular than anticipated, and today over 5 million Raspberry Pis have been sold. It's 2015 data in fact. So, you can think of it that how popular Raspberry Pis. There are various different models of Raspberry Pis that are available today. This is just a glimpse of different types of Raspberry Pi, the latest being Raspberry Pi 5. Now, what is there in Raspberry Pi 5? Well, it has a faster CPU system which has 2.4 gigahertz quad core 64-bit ARM Cortex. So, it is a very fast, up to 3 times faster than other generations. It has improved connectivity. Raspberry Pi has Wi-Fi and about speed of up to 2.5 Gbps, Ethernet, Bluetooth 5.0. It also has PCIe 2.0 interface. It has a power button that you can use to turn the device on and off naturally, and then it has a real time clock, so that you can control the clock speed of the system. Then this is audio jack present in the system, and 2 gigabyte, 4 gigabyte, 8 gigabyte different types of RAM variants, and there are other features like HDMI display output, micro SD card slot, USB ports, etc. So, depending on typical specification of the Raspberry Pi, you can get or you can customize all these extra outputs to you. So, if you look at this system now, very interestingly, you have the core CPU inside. So, this is having a CPU and dedicated graphics unit here, and around the whole system you have these GPIO interfaces. Okay. You have the power button, you have the USB part, you have the micro HDMI ports, you have a transceiver for camera or display transceiver, you have the Ethernet connectivity, you have the USB ports, fan connector to cool the entire system. So, it is a big system arranged keeping all the possibilities of safety. Now, setting up Raspberry Pi. So, Raspberry Pi 5 you need micro SD card, more expensive, I already told you, power supply, micro HDMI cable, monitor, keyboard and mouse, and use Raspberry Pi imager to flash the Raspberry Pi operating system onto the micro SD card. That is the first part, and then insert the card, connect peripherals and put the power on and set up the operating system. So, you will get a follow on screen to set up the operating system. Okay. And your knowledge that is needed is Python or C++. Earlier you needed only the knowledge of IDE, which is very simple, but here you need the knowledge of Python or C++. And now there are various operating systems with which Raspberry Pi is compatible: Ubuntu, Snappy Ubuntu Core, Windows 10 IoT Core, OSMC, some of the popular ones. Okay. So, now some HATs expand the functionality of the Raspberry Pi 5, okay, like Raspberry Pi M.2 HAT plus. This enables the connection of more peripherals like NVMe SSDs, PCIe interfaces, okay, for high speed storage solution. Sometimes storage becomes a problem. Then there are other HATs like LHAT plus. So, in which it has a built-in neural network accelerator, so that it becomes a power efficient AI device, so that you can use it for neural training suitable for machine learning applications. You can also have Raspberry Pis with the USB 3.2 hat, etc., and this is used for high speed networking, so that it can support 4G, 5G modules. So, you can have a quick communication with the environment, and sometimes you will get a HAD of Radix SATA, which is ideal for building a compact network attached storage system. Sometimes the storage may become a problem, you need to also time to time offload the data. So, in all such cases you need a fast access to a network and sort of offload the data to the network. So, there these kind of a HAT is going to help you. Now, there are few more single board microprocessors like Raspberry Pi, like Orange, NanoPi or Droid, Okay, Rock PI, NVIDIA Jetson Nano is a very popular one that we utilize. I will show you some of the applications of all these systems in our case studies. So, where to use Raspberry Pi? Raspberry Pi can be used in all the projects that Arduino can do, because it is more generic, but particularly projects that needs more computational processes, there you need it. Some examples are like NLP type of applications for ChatGPT, or integrating a camera with Raspberry Pi to perform object detection, or using Raspberry Pi as IoT server. These are some of the examples where you can use this system. Now, for applying this Raspberry Pi for robotic applications, you need to use ROS, or a robot operating system, okay, which has a set of software libraries, and originally it is developed in 2007 by Stanford AI Lab, and then there are many OSRF or open source foundation from which you can get the ROSes. Okay. Now, before ROS there were the lack of standards, there were lack of code reusability, etc. So, once we have the ROS, we get actually much more standardized robotic systems with us. So, the philosophy of the ROS is that it is peer-to-peer. First of all, it can consist of many small programs or nodes which connect each other and continuously exchange messages. Then there are tool based, many small generic programs that can perform specific tasks. It can be multilingual also, C++, Python, Lisp, Java, JavaScript, MATLAB, Ruby. You can use many of these type of systems for running the ROS, and it is thin, that is, the ROS conventions encourage contributors to create standalone libraries, and then other people can use it. Okay. So, free and open source community based kind of repositories. So, some robots which are using ROS, we have given you a huge group of things here, which of course includes our favorite now, and then there is many other like this Marlins, Miabot Pro, and then there are Legos there, okay, Turtlebots, and various other robots that use the ROS today. And then in order to simulate, before you actually add the hardware, the ROS can be simulated in two platforms. The most popular one is called Gazebo and the other one is RVs. So, a simulator that places robots in the virtual world, you define the abstractions, give the commands and see how the trajectory is, and RVs shows the robot's perception of the world. So, that is something where from the robot's point of view you can see how the world is perceived. So, we have discussed in today's lecture the microcontrollers, microprocessors, and the very flavor of the robot operating system. All these things are the basic requirement to build an intelligent system or robot. Thank you.